Okay, so this is lesson 1-7. This is the last lesson of the chapter. It's called Words, Equations, Tables, and Graphs. So you might have to make some graphs in your notes. You might have to write some equations in your notes. So be prepared for all of it, because we're going to talk about majority of these things today. And some of it will look familiar to you if you kind of looked at it yesterday a little bit. All right, so an equation. You've heard of an equation your whole life, but this is the actual definition of an equation. A sentence, a math sentence, stating that two things are equal. So if it has an equal sign in it, it's some kind of equation. Equation stating that two quantities are equal. And you don't have to move on to this yet. Okay, I'm going to talk about this in a second. So I'm going to just show you what an equation would look like. That's an equation. You've been talking about that since you've been in probably second grade, first grade even. Yeah. Okay. This could also be an equation. Does that look familiar? Okay, you worked with that a little bit last year. That's also an equation. Okay. So there's equations that are simpler and there's more complex ones. All right. So there are 4 different ways you can see equations, believe it or not. And if you open your book to page 38, I'm going to show you what each of these look like. So open your book to page 38. Page 38. If you look, it says, on page 38, it says multiple representations. Now, if you look at this, that is 4 different ways to write one thing. You can write it in words, and you can, if you look down, you see the table, and then you look over and see equation, and you see graph. Actually, you've done a few of these things already. We just did it on the board together for 32 and 33. We just, made a table, and we made a graph. So we've done some of this already. Some of the only different things might be the equation part of it, and even for the words, you guys have read that before. Even when you read that on the number 32 and 33, you're basically reading the equation. And sometimes you got to write it, right? So you've seen all these things before, and you can write an equation in those 4 different ways, believe it or not. And we're going to focus on we're actually going to focus on all of it, but at least you have some background knowledge of what some of these are already. Okay? So if you want to write these down, you can, but it's not necessarily important. Words, equations, tables, and graphs. Okay? So what we're going to start with is we're given an equation, and we're going to start by making a table. Okay, we're going to make a table just to show you how this works. So here's my equation, t divided by 12, and n equals, t divided by 12, and n equals what? What does it tell me that n equals? Messages, and what's t equal? Okay, make a table to find out the number of messages in 120, 180, 240, and 300 minutes. So what's t again? Okay, so are they giving me the time in there already? Why can't I move this thing? 300 minutes. Let me see. They give me 120. They give me 180. They give me 240. And they give me 300, right? Okay, now why do I have the rule here? What does that mean? That's what I got to do, right? That's what they told me. T divided by 100 equals n, remember? So I'm going to write it in here. T divided by, was it 12 equals n? And then I'm going to put that in there too. Yeah, I was just showing you what I was actually going to do in there. So now I'm going to write 120 divided by 12 equals my n. So what's 120 divided by 12? Just 10. So how many messages were left? Yeah, that's it. You do the same thing. 180 divided by 12 equals n, whatever that is. I'm guessing it's 12. I don't know, should we see? We'll quick do it. Okay, do it in your head. You have to be 15. 15. 15. Yes, it is. Carter, do the next one. Do the next one. Oh, that's an easy one. Do the 300 one. 240. 240 divided by 12 would be what? 20. This is 20. What's 300 divided by 12? Yep. Is it even in the book? It does go up by 5. And if you look, is there a pattern? All right. So this is how you'd make a table, and this is what like number 32 and 33 were about yesterday. Okay. Let's keep going. Come on, really? All right. So now I'm going to turn it around, and I'm going to give you what one side is and what the other side is, and it's your job to come up with the rule. What's happening? What am I doing to X to get to Y? What am I doing to X to get to Y? What am I doing to X to get to Y every single time? Emily? I'm timesing it by 4. You're going to have to probably do this too. They're going to give you something, and you have to come up with what's going on. Okay, let's see if we can do this one. What's my rule? Ooh, I know this one. No, I don't want you to yell it out. Think about it. Everybody's got to think about it. What am I doing? If you don't know what it is, what am I doing to X to get to Y? And then think about it. Does it work for this one? Does it work for this one? Sometimes you have to play around with it. What am I doing to X to get to Y? We're just going to think. I go from 2 to 5, then 3 to 7, then 4 to 9. What's my rule? Is anybody confused about what I'm asking? Anybody confused about what I'm asking? Olivia, you think you know the rule? All right, you guys ready to hear it? See if she gets it right. Okay, time 2 plus 1. Yep. So this is how I would write my rule then. This is how I would write my rule. I take 2 times whatever's in my... Whoa, whoa, whoa. Why are we talking? I take 2 times whatever's in my X, and then what I'm going to do? Pat, plus 1. And that gives me what's in my Y. Does that make sense? What did you do? Okay, so here's the thing about the rule. It has to stay consistent through the whole thing. It's not consistent. Okay? If I add 3 here, I need to add 3 here to get that one. I know. You're doing plus 3, plus 4, plus 5. But that rule is not consistent for every single thing in here. I want one rule that's going to tell me what's going to work for the whole thing. So sorry, that doesn't work. If you see something like that, though, most likely you got to multiply by 2 and then add 1 or subtract 1. Okay? But I see what you're doing. But it has to stay consistent. This has to work for every single one. You can't do like, well, this rule's plus 3, this rule's plus 4, this rule's plus 5. It doesn't work like that. Harley. Got it? Question? No? Okay. All right, let's see if we got another one. Oh, no, we got a different one. Okay, complete the table. State the domain and range. I want you to complete this table, and then I want you to tell me what the rule is. Here's the instructions. I want you to complete this table, so you should have 4 things over here, and I want you to tell me what the rule is. I don't want to hear your voice. You can do it in your notebook, that's fine. It's probably a good idea to have some kind of example. probably almost done. Okay, so if you're not done yet, that's okay. Finish up. But let's go back. What were the 4 ways that things can be written again, that equations can be written? Give me one. Hannah. Okay, words. Give me another one. Graph. Give me another one. Table. Got one more? Equation. Okay. So let's talk about this quickly. Guess what form this is? Words. Okay. What's this one? That's the equation. This one is obviously graph. Table. But could you graph this? Okay, so let's finish this out. This should probably be? Okay. Now, could you graph this? Okay, so tell me what you would do to graph this. What would you do to start graphing this? Okay, you would do number of touchdowns on the bottom, x-axis. Good. Keep going. Could I go 6, 12, 30, 42 on my side? What would I have to do? I'd have to keep going by 6 and be consistent. 6, 12, 18, so on and so forth. Very good. Then what would I do? Plot my points. I'd go over to 1, up to 6, over to 2, up to 12. So we're basically talking about the 4 different ways to write equations today and showing how to do that. Okay. Ready for another? Oh, this is a trickier one. Bob spent 5 more than 3 times what Anna spent. This is a little trickier rule. Bob spent 5 more. What's 5 more mean? Okay, plus 5. Then 3 times what Anna spent. What do we not know here? We don't know what Anna spends, right? But is it 3 times what she spends and then 5 more? So what does my rule or equation look like, John? Oh, you're putting this in. Okay, it's 3 times whatever's in my x, you're right, plus that 5. Good. Does everybody know where I get that x? I use that so I can substitute, okay, 2 in there, 4 in there, and so on and so forth. Okay? So, y would be what? Let's start thinking here. What's this going to be? 11? For 4? 17. Then it's 23. 29. This should go up by the same amount each time. It should go up by 6 each time. If you look, see how this goes up by 2 each time? Then this should have some kind of pattern over there too. There should be some kind of pattern there. Could you graph this? Is this making more sense with your homework now? Okay. Let's see, what else do I got here? Okay, let's talk about your homework.